Hi, in this video we will give you an overview of software testing and why it's so important. Here you see the software development lifecycle, where you have these different phases. We have planning, requirements analysis, design, implementation, and then we have the testing phase, which is a very important phase in the software development lifecycle. And finally, when the software has been tested, you can deploy it to the customers. Here we see some typical software documentation you create during the software development. You typically start with a software development plan, and then you have some high-level requirements and design documents, which describes what the system should do and how it should do it in a high-level description. And then typically you go into more details. You create entity relationship diagrams and database diagrams. You create UML diagrams, computer-aided drawings, etc. of the hardware and the connection between the different pieces the system consists of. And then in the testing, you typically create a test plan where you include how you should test, when you should test, what you should test, etc. And then you need to typically document your testing in some test documentation, where you prove that you have tested and that the software works as expected. And then typically you need some system documentation, where you include the technical stuff, how the system is working, etc. And also typically you have an installation guide, how you install the system. And then finally you need some user manuals or user instructions, how to use the system. So the main purpose of testing is, of course, to find bugs and to find many bugs as possible. Here you see an overview of typical bugs and where you can find them. So in the requirements and the error in requirements, you typically find 13% of the bugs. The design errors is 24%. In the coding, you typically have 38%. And in the documentation, you have typically 13%. And typically, bad fix errors, you fix errors, but then you create new errors. So typically here we have 12%. So why is it important to find bugs early in the development life cycle? Here you see the different phases: requirements, design, implementation, testing, and deployment. And early we find bugs in the software development lifecycle, easier it is to fix it, and it costs less money. When we are almost finished development the system, and then we find important bugs, then they cost lots of money to fix these kind of bugs. Here we actually see the first bug ever found in a computer system. So this bug, actually a mob, was found inside a computer in 1947 that made the program not behave as expected. So this was actually the first real bug in the history of computers. So what is actually bugs? A bug is a software bug. It's an error or flaw or failure or fault in a computer program or system that produced an incorrect and unexpected results or cause it to behave in an unintended ways. And the first bug was found in 1947, as mentioned. This was the first bug. And then we have the debugging phase, where we actually find and remove or fix the bugs. So software testing is very important in software development, and you could say if you don't know how your code works, it does not work. You just don't know it yet. So I guess 50% of the software development is about testing your software to make it work as expected. It's also important to note that different systems need different kind of testing. Here we have 4 different software systems. Number 1 here is a game. Number 2 is a word processing software. Number 3 is a SCADA system, where this system actually control a real plant in a process in a factory. Then number 4, it's a system, health system used in medical systems in a hospital. So all these systems and others need to be tested in different ways. Here in the games, it's not so critical that you have critical bugs, while in process systems that control a factory or systems that take care of patient in a hospital is of more critical art than games and word processing systems. So all kind of systems need to be tested in different ways. Here we see 7 important principles of testing. And number 1, testing shows the presence of bugs. Software testing reduces the probability of undiscovered defects remaining in the software, but even if no defects are found, it is not a proof of correctness. This means even if you are not able to find bugs, the software is not completely bug-free. Number 2, exhaustive testing is impossible. So testing everything is impossible. Instead, we need to optimal amount of testing based on the risk assessment of the application. So we need to focus on some important area within the application that we focus most of the testing on. Number 3, early testing. So testing should start as early as possible in the software development lifecycle. And so typically you also start creating tests before you start developing code, so-called unit testing. Number 4, defect clustering. So a small number of modules contain most of the defects or bugs detected. So then it's obviously important to focus on these modules when you're looking for bugs. Number 5, the pesticide paradox. If the same tests are repeated over and over again, eventually the same test cases will no longer find new bugs. And then, of course, we need to create new test cases in order to find these bugs that is still there. Number 6, testing is context dependent. This means that the way you test a e-commerce site will be different from the way you test a commercial site. As I showed in an earlier slide, you need to test different systems in a different ways. So number 7, absence of error is fallacy. So finding and fixing defects does not help if the system build is unusable and does not fulfill the user needs and requirements. So you should always test your system and compare it to the requirements and design documentation, because it doesn't help if the code itself is almost bug-free if the user or the customer don't want to use it because it doesn't fulfill the requirements from the users. So these are 7 important principles in testing that you should be noticed about. Next, we will talk about different types of testing. So we have lots of different types of testing. Here are just some examples: non-functional testing, stress testing, setup and deployment testing, functional testing, load testing, security testing, requirements testing, performance testing, graphical user interface testing, usability testing, regression testing, etc. All these testing is important to have in mind when you are going to test your program. So who actually does the testing? We can, I guess, divide it into three parts: the programmers or developer. Of course, he needs to test his own program. And in addition, we have independent testers and test groups that is testing the software. Then, of course, we have the end users or the customers, the persons that are actually going to use the software when it's finished. So it's important that the customer is part of the testing during the development of the software. So testing can be divided into two test categories, and the first one is black box testing, and the second one is white box testing. So black box testing, and then you don't need to know anything about the system you are going to test. So typically testers test the system in this way, while white box testing, then you need to know or have detailed knowledge of how the system is built. So typically this is done by developers or more advanced testers, system architects, etc. You can also divide testing into different levels. Here I show 4 different levels. In the bottom, you start with this one. It's unit testing. So you should test any module or program or object separately. This is typically done by the developer. He creates so-called unit test that the code is tested against. And typically you create the unit test before you start developing your code. Then you have integration testing, where you test the interface between components and the interactions with other systems. It could be operating system, hardware, etc. Then we have system testing, and that's the behavior of the whole system or product that is defined by the scope of the development project. So you need to test the whole system and how it's working overall. And then finally we have acceptance testing. That's the responsibility of the customer in general. So the goal is to make sure that the system is working as the customer wants it to be. So all these levels of testing are very important. So let's repeat unit testing, and we need to test each part independently and isolated. So each part in the puzzle needs to be tested independently, and this is typically done by the developer. And then we have integration testing that makes sure the different pieces work together, and you need to test the interfaces between the different pieces and the interaction with other systems like hardware, operating system, etc. So you need to test how different pieces are working together. Then we have number 3, system testing. Then we need to test the whole system, in this case the whole puzzle, to see if everything works as expected. When you find bugs and the developer fixes these bugs, you should always do regression testing, and that is to test that the system is still working after you have made some changes in the code. So either this could be typically if you find bugs and then you fix them, typically you create new bugs, or if you create new functionality in your program, you typically also create some bugs. So this is what we call regression testing. So these levels of testing typically go into a loop from you start developing your program until you are finished. So you do these levels of testing until you consider that the program is finished and should be used by the customer. So then, of course, you always start with unit testing. If you are doing changing in the code, you need to do regression testing. Then, of course, integration testing and system testing. And if you find bugs in these, of course, you need to go back, fix it, and do these tests all over again. And finally, at some point, you think the software is finished and can be finally accepted by the customer, and then the customer, together with the company that produced the software, is performing an acceptance testing. So the customer needs to test and approve the software before he can take it into use. So this is what you call acceptance testing. So let's summarize. We have these test categories: black box testing and white box testing. And we have these different kind of test levels: unit testing, regression testing, integration testing, system testing, and acceptance testing. And all these require different test methods. You need to test the graphical user interface. You need to do some stress testing and load testing. This means you need to test the system with many users and a big amount of data. Typically, if you get some data from a database, you cannot test the database with a small amount of data into the database. You need to test it with a large amount of data. Of course, security is important in modern software. You need to test it regarding security, usability. Is your program user-friendly? Performance. Is it fast enough for the customer to use? Does it have the functional and non-functional requirements according to the functional and non-functional requirements in the software requirements specifications, etc. Next, we will talk about the software test plan, which is an important document in order to focus on what should be tested, how we should test, when, etc. So all these things should be included in a software test plan. So test planning is to maximize the effectiveness of resources spent on testing and have a systematic approach when testing is very important. That's why we should create and use a software test plan. Here we see typically the test documentation made during a software development project. So we start with the software design. We start with the software requirement specification document and the software design document. These are very important documents when it comes to testing. So then we need to take all these things into consideration when we are planning the testing, and these things should be listed in the software test plan. And then we start performing the tests, and then we document the test results, report the bugs in a bug reporting and tracking system. This goes into a loop until the software is finally developed and all important bugs are found. Then finally, we should create a software test documentation where we document all these things so the customer can rely on that the software is tested and are ready to use. So what is a software test plan? This is a document that answers the following questions. That testing should be based on requirements and design documents. What shall be tested? How shall we test? Any hardware and software requirements that we need to take into consideration when we are testing? Where shall we test? Who shall test? And how often shall we test? Make a test schedule. And how shall these tests be documented? It's not enough simply to run tests. The results of the test must be systematically recorded. It must be possible to audit the testing process to check that it has actually been carried out correctly. So you need to have a software bug reporting tool and a software testing and tracking tool. So you can track all these bugs in a systematically way. And also the last one, system test. So this section, which may be completely separate from the test plan, defines the test cases that should be applied to the system, and these tests are derived from the system requirement specification. So all these things should be included in the software test plan. So this is a very important document when you are going to start planning the testing and execute the testing of your software. I guess these are the main things that needs to be specified in the software test plan. So you start with the requirements document, and based on that you create test specifications. Which human resources should be part of the testing? Of course, you need some environment in order to test the software, and these things of course need to be specified in the software test plan. When you have all these things in place, you are ready to start the testing. Here we see an example of such a test plan. Of course, there are no absolute way to do this, but this is just an example. So you can divide it into these chapters, where you start with goals and exit criteria regarding quality, robustness, etc. And you have, of course, a test schedule. It's important. And B, items to be tested and inspected. And number C, test processor or test methods. What kind of methods are you focus on in your development regarding this unit testing, functional testing, acceptance testing, regression testing, and this black box and white box testing. So what kind of methods are important to use in your software? All these things need to be part of the test plan. And the process of how to report the bugs also needs to be documented. What kind of software are you going to use? How are you going to use that system? And the process and the steps in order to report bugs and track the bugs using these kind of systems. Resources, the people that are going to test, and here also of course the tools, as I mentioned here, the test environment. How are you going to create the test environment? Are you going to use a virtual test environment? Who are responsible to create and maintain these environments? Schedule. When are the tests going to be done, etc. And of course, any risk regarding the testing. If your system could cause danger of lives, etc., of course, these things need to be considered here. And of course, you need to include the major test scenarios and test cases. We'll discuss these topics a little bit later in this video. So here we see some things that you need to consider when you are making the test plan. So of course you should always start to analyze the product in order to figure out how your product is going to be tested. And then based on that, design a test strategy. And of course define the goal with the testing. What is the purpose with the testing of this software system? And then plan the test environment, the resource planning, who are going to test the system, etc. Then you need to define some test criteria. When are you actually finished with the testing? We'll talk more about these things later in the video. Then schedule an estimation. When are you going to test? What will the test cost you? Of course, as I said earlier, testing is 50% of the total development time. So of course testing is very cost a lot of money, but again, testing is very important in order to find critical bugs in the system before you start using it. Here we see an example of a typical test cases document. In this document, it could be an Excel document. In this document, you just list all the test cases you are going to perform during the testing. In the top of the document, you should of course include the name of the tester and the date when he tested. And then the tester should go through all these test cases. It could be many hundred test cases depending on how large your software program is. And then for each test case, it should be either okay or failed. And if the test failed, you need to include a description of what is wrong regarding the test case. And then, of course, these things need to be added to the bug reporting and tracking system as well. So these test cases lists should be typically filled out electronically, and then it should be included as part of the software test documentation. So let's summarize the test planning phase. So test planning is not a static document, but it's involved during the development process. So it's a living document that you need to change during the development lifecycle. And test planning is particularly important in large software system. When you develop large software systems, for small or medium-sized systems that has a less formal structure, then you can use a less formal test plan. But there is still important to have a formal document to support the planning of the testing. So you should, even if you're developing a small software system, you should have some kind of a test plan. That's very important. Next, we will talk about the test environment. So why do we actually need a test environment? Why can't we just use your own PC? Why do we need a separate test environment? So here are some reasons. Typically, the developer always says, it works on my computer. And actually, it's in many cases, that's the case. Because the computer that the developer are using, of course, it has all the development tools, etc. But when you're going to actually install the software in the customer location, the customer don't have all these tools that the developer use when he developed the software. So typically, it always works on the computer that the developer are using, but that's not the PC that the system should run on when it's finished. So when testing, it's also important to have a clean environment. Start from scratch with an empty PC and an empty operating system, and then you install your software on that system together with other components you need in order to test your system. Also, we need to test the software on different platforms and operating system. So we need to have different kind of test environments. Typically, if the system or software should be used on Windows, Mac or Linux, we need to test the software on these different platforms. Also, of course, we have lots of different operating systems. We have Windows, different kinds of Windows. We have Windows XP, Windows 7, Windows 8, Windows 10, etc. So all these operating systems, we need to test our software on these different operating systems. Now, of course, if our software uses some kind of a web browser, we need to test the software on these different web browsers. So we have at least you should test your software on the main web browser that do exist today. Typically, we have Microsoft Explorer or Microsoft Edge. We have Chrome from Google. We have Safari from Apple. And we have Opera and of course Firefox. These are I guess the main 5-6 browsers we should test our system on. And of course, deployment. We need, in order to deploy the software on the customer's computer, we need to create some installation package. And of course, these packages need to be tested out before the customer can use them in order to install the software. And also, it's more than the developer that are going to test the software, so it's important to make the software available for testing for the testers that are actually going to test the software. So based on that, it's important that you test the software on other computers than your own. So make sure that typically, so everything works on the developer computer, but typically, if you're using a database, the customer's database is typically not the same as the database you have on your development computer, or the customer may use different operating system than you are using, or they use different web browsers, and of course, you are using development tools like Visual Studio, etc. But the customer don't have these software installed. So all these things makes it very useful to use a separate test environment in order to test your software. So here we see a typical scenario where you have the development environment. So typically the developer's personal computer has the database, web server, and the programming software installed. And of course, typically everything works perfect here. But when you take your software on a clean environment without these softwares, you typically find lots of bugs. So you should always use a separate test environment. And typically you need several computers in order to test your software. You need a database server, web server, some clients with different operating system and different web browsers, etc. Typically, you set up a virtual test environment where you use some kind of virtual software in order to do these testings. And then finally, then you have the production environment. This is the customer environment where you are actually are going to install the software when it's finished. But before you install it in the production environment, you need to test the software in the test environment. So using virtualization is typically a good choice when you're going to create the test environment, because then you don't need lots of computers, etc. You can install different operating system and different web browsers, etc. in a virtual environment on the same computer. And then you can install your software on these virtual machines. And when you are finished testing, you can reset the test environment and then start from scratch. We have lots of virtualization software we can use in creating our test environment on the market today. Some of them costs a lot of money, while others are free of charge. So we have software from VMware. We have virtualization software from Microsoft, VirtualBox, etc. So all these are good software when we want to create a virtual test environment. So VMware Workstation Player is free for personal use. You can use it on your own computer, and you can use it for free for personal and non-commercial use. And within that software you can install lots of virtual machines which you can use for your testing. Next we will discuss how much time you should do on testing and when you are actually finished testing. As mentioned earlier, 50% of the software development is about testing your software. So when are you actually finished with the testing? So here we see an example. We start with requirements and design, and we have different releases during the project. Typically an alpha release, beta release, release candidate, and a release to manufacturing, and a final delivery. And then of course we should test during the whole project, but of course you also increase focus on testing in these internal releases like the beta, release candidate, etc. But even if you test very much, you can never find all the bugs. So release software do actually have bugs. So when should we stop testing? A simple answer to that is to stop testing when all the planned test cases are executed and all the problem found or bugs are fixed. But in reality, it may not be that simple. We are often pressured to schedule and release the software on time. So we need to release the software even if it contains some bugs. And today it's also easier to release bug fixes. In the old days you release the software on CDs and you ship them to the customer in the mail, and it could take many weeks. But today most of the software, they just download bug fixes automatically. So it's easier to fix bugs even when you have released the software. Here we see a chart here. On the Y scale we have software finished, and here on X scale we have time used to develop the software. And you see here 90% when the software is 90% finished. I guess we are 90% finished with the software here, but the last 10% takes, as you see, very much time. So sooner or later you have to say enough is enough and release version 1.0. So you must define within a development company or development team or in dialogue with the customer what is defined as good enough, because software will never be 100% complete or error-free. Here we see another chart. This red line see number of bugs in the development time. In the beginning, of course, there's no bugs, but then lots of bugs appear, and then we start fixing them, and then number of bugs should be go to 0 after an infinite time. But here in green you see also the resources or effort to find the bugs. In the beginning it's very easy to find bugs, but then when you have tested the software for a long time and the most critical bugs are gone, it takes a lot of time and effort and resources to find new bugs. So then at a point we reach this critical point where we should ask ourselves, should we test more, or should we be finished with the testing? And of course these things depends on the time, when should you release the software, the budget, etc. So all these things you should take these into consideration. So it's important to set or make some criteria when we should stop testing. Typically we could make some of these criteria. So when the tester has not been able to find another bug or defect in let's say 5, 10, 30 or 100 minutes of testing, then you should stop testing. Another criteria could be when all code reviews and walkthroughs have been certified and the code seems to be okay. A third one, when a given checklist of test types has been completed. Another test criteria could be the code has passed all the unit tests, or of course when testing runs out of its scheduled time. And here, so you should typically make a list of criteria when to stop testing and when you consider the testing should be finished. And these things should be included in the software test plan. Next, we will talk about bug tracking systems, because when you spend lots of time testing the system, you find lots of bugs. These bugs need to be reported into a computer system, so you keep track of the bugs. You can easily make bug lists, so the developer can easily find the bugs or track the bugs in the bug tracking system, prioritize them and start fixing the bugs. So what is a bug tracking system? A bug tracking system or a defect tracking system is a software application that keeps track of reported software bugs in software development project. It also may be regarded as a type of issue tracking system, and typically bug tracking systems are integrated with other software or project management applications. Here we see some examples of bug tracking system or software. We have Team Foundation Server or Visual Studio Team Services, which is a cloud-based version of Team Foundation Server. We have Jira, Bugzilla, ClearQuest, but we have hundreds of different bug tracking systems. Here we see an example of how the different roles in a development team use the bug reporting and tracking system. So we have the developer, we have one or more testers, and we have a project or test manager, and the tester typically report the bugs into the bug tracking system. We have some test manager that could assign the bugs to a responsible person, and then the developer get a list of bugs he needs to fix, and then when the bugs are fixed, he needs to update the status in the bug tracking system, and then the tester can get a new list with bugs that are fixed by the developer, and he needs to go through that list to check if the bugs are actually fixed, and if they are not fixed, they need to be put back in the bug tracking system, and then the developer can check if the bugs fixes are approved by the tester or the test manager. So that's how the different roles uses a bug reporting and tracking system. Now we will show some of the bug tracking features in Visual Studio Team Services. In Visual Studio Team Services, we have what we call work items, and we have different kind of work items. We have a work item called bugs, which we use to report bugs in the system, and then of course we just select new here, and then you can report new bugs into the system. Then we will get a list of work items, and then we can click on them to get detailed information about the bugs. You can also use something called queries to make different lists of bugs. So here is an example of the new bug work item. So here we can enter a title. Here we can assign a person that should be fixing the bugs, in which application the bugs are found, in which iteration the bugs are found. You can make a priority. We can write some information how to reproduce the bug, etc. And then you can use something called queries to find the bugs that is reported in the system. So you can make or create different queries to make it easy to find the work items you need. And the queries can be either personal, or you can make them visible for everybody in a team, so-called team queries. So here you see an example of how to make a new query. So here you set some search criteria, typically which project you are working in, a work item type. In this case, typically you select a bug, and which state the bug are, if it's fixed, not fixed, approved, etc. And here you can also set different kind of criteria. And based on these criteria, you will get a list that fulfills these criteria. And then it's very easy to find the bugs you need in the system. Next, we will talk about code reviews and refactoring, because performing code reviews within a team is an important part of the testing phase. Because then we can find bugs in application before they actually appear, and based on the code review, we can actually change the code and make it better before the bugs actually appear. So refactoring is about to improve your code without actually altering its behavior. So it's to make your code more robust, and then you probably create fewer bugs within your software. So you should always spend time on code reviews and refactoring as part of the testing within your software. So that's all for now. So good luck with the software testing.